All right, welcome to the deep dive. Today we're getting into something, well, pretty fundamental for anyone building or using these LLM-based agents that are, getting more and more capable. How do we actually know if they're getting better?
Yeah, good question. It's not enough to just feel like they're getting smarter, right? We need solid ways to measure that progress.
Exactly. And that's where this deep dive comes in. We're going through a pretty comprehensive survey on the state of evaluating these complex systems. It's packed with insights that are honestly essential for anyone working in the field, especially AI researchers and ML engineers, so you folks can really stay ahead of the curve. We're talking about everything from how we test basic capabilities like planning and tool use to those specific real-world situations, like how well an agent can browse the web or write code. And of course, we'll look at those benchmarks, trying to figure out how good those general-purpose agents are becoming. And then, the tools and frameworks developers are using to make sense of it all.
Right. And what really jumps out from this survey is that we're moving towards more realistic, challenging evaluations. Plus, we're seeing the rise of those live benchmarks that are constantly evolving.
Which makes total sense because the field itself is moving so fast.
Yeah.
But the survey also points out some big gaps where we need more, I guess you could say, rigorous assessments. Things like how cost efficient these agents are, how safe they are, the stuff that really matters when we start deploying them more widely.
Exactly. It's not just about performance anymore. It's about the whole package.
All right, so this survey really breaks it down, starts with the basics. How do we test those core abilities? The things any intelligent agent needs. Planning, using tools, even a bit of self-reflection and memory, those kinds of things.
Right, the foundation.
Then we get into how these agents perform in specific contexts, like navigating the web or, writing code.
So putting those core skills to work in the real world.
Exactly. After that, it's those benchmarks, trying to assess how good those general-purpose agents are. And finally, all those toolkits and frameworks that developers are using to do all this evaluation.
So it's kind of like a layered approach.
Yeah.
And it's clear that compared to those earlier evaluations of LLMs, which were, mainly about language generation, we're dealing with a whole new level of complexity with these agents.
Yeah. We're not just judging how well they write poems or summarize text anymore.
Right. Now we're evaluating their ability to act in the world, interact with tools, make sequential decisions.
It's a whole different ballgame.
And that's why we need this much more, richer and definitely more dynamic set of evaluation methods.
Okay, so let's start with that planning and multi-step reasoning. I mean, if an agent can't plan, it's going to have a hard time doing anything more than, well, the simplest tasks, right?
Exactly. That's where it all begins.
So how are we currently assessing this? What are the benchmarks looking like?
Well, the survey highlights that there's a ton of variety in how we're approaching it, which kind of reflects the complexity of planning itself, right? You've got mathematical reasoning, things like AQA-RAT, GSM-8K, math problems that really need multiple steps to solve.
So it's not just about knowing the formulas, it's about using them in a sequence.
Exactly. Then there are those multi-hop question answering benchmarks, stuff like hotpot QA and strategy QA, where the agent has to, pull information from different places and piece it together. And you've got logical reasoning being assessed with things like RC, Folio, and P-Folio.
And then there are those benchmarks that, well, they feel a bit more like puzzles, right?
Yeah, things like Game of 24 and MIT, they challenge the agent to solve more creative, out-of-the-box problems. And even common sense reasoning, that stuff we humans take for granted, that's tested in multi-step contexts with MUSR.
So it's like each benchmark is shining a light on a different facet of what planning really means.
Yeah, trying to isolate those core components.
Are there any frameworks that are, trying to look at it more holistically, not just focusing on one specific kind of planning?
Definitely. There are some that are taking a much more integrated approach. Tool Emu, for instance, that one uses simulated environments, and it specifically looks at planning when it comes to using tools. So it focuses on the agent's ability to track the environment, recover from errors, that sort of thing.
So not just picking the right tool, but actually using it effectively in a changing situation.
Exactly. And then there's MINT, which puts the agents in those interactive settings. It's specifically designed for those long horizon tasks where the planning needs to play out over, many, many steps.
So those tasks where you really have to think ahead.
Yeah, where short-sightedness just won't cut it.
Yeah.
Plan bench is interesting too. That one distinguishes between that short-term, tactical planning versus longer-term strategic planning.
I guess kind of like the difference between winning a single battle and winning the whole war.
Exactly. And what's interesting is that agents, at least for now, seem to be much better at that short-term stuff.
Makes you wonder why.
It does, doesn't it? Then there's auto plan bench. which focuses on everyday planning, those scenarios we encounter all the time.
So more grounded in the real world.
Yeah, exactly. And surprisingly, LLM agents are still often lagging behind those traditional symbolic AI planners in those kinds of, well, familiar contexts.
I guess that shows there's still a gap to bridge.
Definitely. Then we've got Flowbench, which concentrates on workflow planning, especially in those more, specialized, expert-heavy domains. ACP Bench is designed to assess those core reasoning skills that underpin effective planning. And finally, you've got Natural Plan. That one tries to evaluate planning using real-world instructions in natural language, which is a whole other challenge.
So making it as close to how we humans actually plan as possible.
Yeah, but it seems like complexity is still a big hurdle there.
It's fascinating to see all these different ways we're testing planning. So when you look at all these benchmarks and frameworks, what are those core abilities they're really trying to get at? What makes a good planner in an LLM agent?
Well, the survey boils it down to a few key things. First, there's task decomposition. That's the ability to take a big, complex goal and break it down into smaller, manageable steps. Then there's state tracking and belief maintenance, which is basically, the agent needs to be aware of the current situation, understand how things are changing as it executes its plan. And then self-correction, that's crucial. Can it identify when it makes a mistake and fix it? Causal understanding, that's the ability to predict the consequences of actions. And meta-planning, this one's about reflecting on and improving its own planning process.
So it's not just about planning a single task, it's about getting better at planning in general.
Exactly. It's a meta-level skill. And these are really the fundamental building blocks for effective, multi-step reasoning in these agents.
Okay, makes sense. Let's move on to function calling and tool use. This feels like the bridge between the LLM's internal world, all that knowledge it has, and the real dynamic world we live in. It's like, how do we get them to actually use all that knowledge to do stuff?
Totally. It's the key to making them truly useful. And the survey points out that when you're evaluating this tool use, there are several subtasks you have to consider.
Okay, break it down for me.
Sure. First, you've got intent recognition. That's, figuring out when a tool is necessary in the first place. Then there's function selection, picking the right tool for the job. Parameter value pair mapping. That's about, taking a user request and translating it into the specific inputs the tool needs. Then, of course, you have to make sure the function is actually executed properly. And finally, the agent needs to generate a response that makes sense, incorporates the tool's output.
It's like a whole pipeline from understanding the need to delivering the results. So how are the benchmarks handling all of that?
Well, early benchmarks, things like Toolpaka, API Bench, Tool Bench, and that first version of BFCL, that's the Berkeley Function Calling Leaderboard, they generally focused on single-step tool use. Pretty straightforward stuff with clearly defined parameters.
So kind of a controlled environment?
Yeah. They often used synthetic data, and they measured things like success rates, how often the agent got it right based on rule-based matching and whether the structure of those function calls was correct. So, pretty basic stuff.
But obviously that's not how it works in the real world. We rarely just use one tool at a time, right? There are often multiple steps, and sometimes we don't even know exactly what we need until we start digging in.
Right, things are messier out here in reality. And that's where the field has really started to evolve. Later versions of BFCL, like V2 and V3, they started incorporating those more complex organizational tools, introduced multi-turn logic, so things play out over several interactions.
So we're getting closer to those real-world scenarios.
Yeah, exactly. The focus is now on continuous state management, keeping track of everything that's happened across multiple turns.
So what are some of the more recent benchmarks that are, really pushing the boundaries here? The ones that are getting closer to how we actually use tools in the wild?
There are a bunch of them, but some that stand out are Tool Sandbox, Seal Tools, API Bank, Nexus Raven, API Blend, REST Bench, AP Gen, and Stable Tool Bench. And each one kind of focuses on a different aspect. Tool Sandbox, for example, it evaluates those stateful tool executions. That's where the output of one tool call can affect the next one, kind of like a chain reaction. It also does those on-policy conversational evaluations with simulated users, which makes things more dynamic and unpredictable.
So less scripted, more like how we'd actually interact with these agents.
Exactly. Seal Tools specifically tests those nested tool calls, which happen all the time in real-world workflows, where you're using one tool to get info that feeds into another tool.
Right, like a chain of dependencies.
Exactly. And API Bank, that one tries to provide realistic API engagements using dialogue-based evaluations. They got a lot of training data to work with, too.
So it's about making those interactions as natural as possible.
Yeah, just like a conversation. Nexus Raven aims for more generalized tool use across all sorts of different scenarios.
So trying to make the agent more adaptable.
Right, not just good at one specific task. API Blend takes a comprehensive approach, focusing on both training and benchmarking. They cover API detection, slot filling, call sequencing, the whole shebang.
So a more holistic view.
Yeah. Then there's REST Bench. That one focuses on using multiple APIs together to, satisfy complex user instructions.
So really testing that coordination and integration capability.
Exactly. API Gen tackles the data side of things. It provides a way to automatically generate those high-quality data sets for function calling, and it uses hierarchical verification to make sure the data is accurate.
So laying the groundwork for even better training and evaluation in the future.
That's the idea. And finally, Stable Tool Bench addresses that tricky issue of API instability. Sometimes APIs change, which can mess up the evaluations.
Right, so it's about making sure those tests are reliable and consistent over time.
Exactly. They use a virtual API server to create a more stable environment for testing.
It's impressive how much effort is going into making these evaluations more robust and realistic.
And we're seeing benchmarks that are really focused on that multi-step complexity, like Complex Func Bench. That one is designed to assess those scenarios where the agent has to figure out implicit parameters, make sure it's following user-defined constraints, and handle that long contextual information.
So less hand-holding, more figuring things out on its own.
Right. And Nestful, that one specifically evaluates how agents handle those nested API call sequences, which is a pretty common thing in the real world.
Okay, so we've covered planning, tool use. Another area that always fascinates me is that self-reflection piece.
Yeah.
The ability for an agent to actually learn from its mistakes, improve its reasoning. How are we even approaching that with LLMs? It seems so, almost human.
It's a cutting-edge area for sure. The idea is to see if agents can kind of step back, analyze their own thought process, learn from feedback, and ultimately make fewer errors in those multi-step tasks.
So less like a rigid program and more like a thinking entity.
Yeah, exactly. More adaptable, less prone to repeating the same mistakes. And the survey points out that early attempts to evaluate this were kind of indirect. Researchers would take those existing reasoning and planning benchmarks, things like AGI-EVIL and ALF World, and they'd kind of shoehorn in multi-turn feedback loops.
So basically giving the agent a chance to correct its initial answer.
Yeah, and then they'd measure whether the agent could actually do that. But
it wasn't a true test of self-reflection.
Right. Just because the final answer was corrected didn't necessarily mean the agent had really reflected on its reasoning.
It could just been a lucky guess. Or maybe it picked up on some cue in the feedback that wasn't really about the reasoning itself.
Exactly. So new benchmarks have popped up to address this. LLF Bench, that's a good example. It's a standardized benchmark with a bunch of different decision-making tasks where the instructions are actually part of the environment, so the agent has to figure things out on the fly. And they use randomization to prevent overfitting.
So preventing the agent from memorizing specific solutions.
Right. LLM Evolve is interesting too. It evaluates self-reflection on standard benchmarks like MMLU by using those past queries and feedback as, in-context demonstrations.
So basically showing the agent how it's done by other agents.
Yeah, kind of like learning by example. And then for coding agents, they've extended benchmarks like APPS and Live Code Bench to those interactive settings so they can get a more fine-grained view of how different types of feedback influence performance.
So really digging into the specifics of how the agent learn.
Yeah. And there's even a benchmark that takes a cognitive science perspective on this whole reflection thing. It's called Reflection Bench, and it breaks down self-reflection into those, core cognitive components. We're talking about perception of new information, memory usage during reflection, how beliefs are updated, adjustments to decision-making, counterfactual reasoning, and even meta-reflection that's thinking about your own thought processes.
Whoa, that's getting deep.
It is, isn't it? But it gives you a much more detailed understanding of what's really going on inside the agent's, mind, for lack of a better term.
All right, let's move on to memory. For agents to really engage in those meaningful long-term interactions and build, persistent knowledge, they need good memory mechanisms, right?
Absolutely. Memory is crucial for anything beyond those, one-shot interactions. And evaluating this for LLM agents means looking at both short-term recall, that's for the immediate context, and long-term retention for that, deeper understanding that develops over time.
So it's like the difference between remembering what you had for breakfast this morning and remembering the capital of France.
Exactly. And one of the biggest challenges here is overcoming the limitations of the context window in current LLMs. They just can't hold everything in their working memory at once. So benchmarks like Read Agent, MEMGPT, and AMEM are all exploring different architectures and strategies for, expanding that memory capacity.
So it's like giving them external hard drives or something.
Yeah, in a way. Read Agent focuses on structuring how the agent reads information, condensing it, and retrieving those relevant memories. It's showing promise on datasets like quality and narrative QA.
So it's not just about storing more, it's about organizing it efficiently too.
Right. MEMGPT uses a tiered memory system, and they've tested it in those multi-session chat scenarios using the natural questions open dataset. AMEM has a more advanced memory architecture and is being assessed using the Locomo benchmark.
So lots of different approaches to tackling this memory bottleneck.
Yeah, and the idea of evaluating episodic memory, that's particularly interesting. Can the agent remember specific events along with the context in which they happened?
Right, not just isolated facts, but the whole story around them.
Exactly. Researchers are using specialized benchmarks for this, often using synthetic data like book chapters, where the agent has to generate memories of specific hints and all the contextual details. And then they use LLM-based judges to evaluate the quality and relevance of those memories.
So LLMs judging other LLMs. That's pretty meta.
It is, isn't it? Then there's StreamBench. That one takes a different tack. It's evaluating how agents can use external memory, including past interactions and feedback, to continuously get better at tasks like text-to-SQL, tool use, and question answering.
So it's not just about remembering the past, it's about using those memories to improve future performance.
Exactly. Memory becomes a key part of the learning process. And there are other benchmarks that focus on this too, like reflection. That one tracks success rates on tasks like Hotpot QA and ALF World, looking at how memory of past attempts informs those future actions. RAISE enhances the React framework with a two-part memory system, and they use human judges to evaluate how effectively the agent is using its memory.
So bringing in that human element to assess something that's, well, pretty hard to quantify.
Yeah. Karma looks at those household tasks, those everyday things, measuring things like success rate, retrieval accuracy, and memory hit rate. And LTM benchmark, that one evaluates conversational agents in those extended multitask interactions where the context is constantly switching.
So it's like jumping between different conversations and remembering what was said in each one.
Exactly. And what's really cool is they found that even those LLMs with limited context windows, if they have a good long-term memory system, they can perform as well as, or even better than, those models with much larger context windows.
So it's not just about the size of the memory, it's about how you use it.
Right. Efficiency is key.
Okay, so we've covered those foundational abilities, how they're being evaluated. Now let's get into the specifics. How are agents being assessed in those, actual application domains? The survey covers web agents, software engineering agents, scientific agents, conversational agents.
Right. It's time to see how those building blocks translate into real-world capabilities.
And it feels like the evaluation approach becomes much more integrated here. It's not just about isolated skills, it's about, end-to-end performance on tasks within a specific environment.
Exactly. These application-specific benchmarks are usually a package deal. They include a data set of relevant tasks, an operating environment, which could be simulated or real world, and often includes those user simulations, specific tools, and even policies the agent needs to follow.
So it's like setting up a mini world for the agent to operate in.
Yeah, and then you need a set of metrics to measure its performance. You've got the overall success rate, but also those more granular measures of, efficiency, accuracy, all those things that matter when you're actually using the agent for a specific purpose.
Okay, so let's start with web agents. How are we evaluating their ability to, navigate and interact with all the complexities of the internet? That seems like a pretty tall order.
It is, but there's been a ton of progress. Early benchmarks like MiniWab and MiniWAB plus off, they focus on those pretty basic things. Navigation, automation tasks, all in very simplified environments.
So baby steps.
Yeah, exactly. Then we started getting those static data sets, things like WebShop, Mind2Web, and WebVoyager. These allowed for offline, reproducible evaluations of more complex things, like online shopping, finding information on the web, that sort of thing. But the real shift has been towards those dynamic online benchmarks that are much more, well, realistic.
Because the web itself is constantly changing.
Right.
A static snapshot isn't really enough.
Exactly. So you've got benchmarks like Bottleneck, that one tests how well the agent adapts to those interface changes on websites. Web Arena and Visual Web Arena, they use realistic UIs and visual cues.
So they're not just dealing with text anymore, they're actually interacting with those graphical elements.
Right. Work Arena and Work Arena Plus simulate those more complex multi-step tasks you'd see in, an office or enterprise environment.
So things like booking travel, scheduling meetings, managing projects, all that stuff that people actually do on the web for work.
Exactly. MMIA offers a multimodal, multi-hop evaluation, while Assistant Bench focuses on those more, realistic tasks that span multiple websites, take more time to complete.
So it's about testing that sustained engagement, not just quick bursts of activity.
Yeah. And Web Canvas, that one provides a very granular analysis by tracking how well the agent completes those, key navigational steps. It's like looking under the hood to see how it's really getting things done.
So we can see where it's excelling and where it might be stumbling.
Exactly. And ST Web Agent Bench, that one tries to combine those static and dynamic elements, get the best of both worlds.
So it's clear that we're getting closer to evaluating these web agents in truly realistic scenarios.
Yeah.
But the survey points out some areas where we're still lagging behind, right?
Yeah, for sure. These benchmarks do a good job of measuring how well the agent can navigate and complete tasks, but those really crucial things like policy compliance, risk mitigation, those safety protocols we need for real-world interactions, those are still largely underevaluated.
Right, because it's one thing to be efficient, it's another thing to be responsible.
Exactly. And as these web agents become more prevalent, addressing these gaps is going to be essential.
Okay, makes sense. Now, what about those software engineering agents? How are we measuring their ability to code, debug, all that good stuff that makes software development tick?
Well, initially we started with those fundamental code generation benchmarks, things like Human Eval and MBPP. They've focused on those short, self-contained coding tasks. And then we moved on to those open domain benchmarks, which were a step forward, but they often involved simpler, intense, limited use of tools.
So still kind of limited in scope.
Yeah. A big leap came with SWE Bench, which uses actual GitHub issues for end-to-end evaluation.
So real-world problems.
Exactly. It includes those issue descriptions, code repositories, validation tests, the whole 9 yards. And they've been iterating on this benchmark, refining it with different versions like SWE Benchlight, Lights, Verified, and Plus, Dallas, each tackling different issues like reliability, data leakage, making it a really robust evaluation tool. And then they expanded it with SWE Bench Multimodal, which brings in those visual software domains, where you're dealing with graphical interfaces and stuff.
It's recognizing that not all software is just lines of code.
Right. And there are other benchmarks focusing on specific aspects, like test generation. You've got TDD Bench Verified and SWT Bench. IT Bench evaluates those IT automation tasks. Agent Bench explores those interactive capabilities in more dynamic environments. And then you've got Swalancer, which tries to link the agent's performance to actual monetary value.
So how much would someone pay for this code?
Yeah, exactly. It introduces those long-term reasoning challenges, too, because it's not just about solving one problem. It's about building a whole portfolio of work.
Wow, it's incredible how specialized these benchmarks are getting.
And it really reflects the complexity of software engineering itself, right? It's not just about writing code anymore. It's about understanding the whole development process, interacting with other developers, even considering the economic implications of the work.
Okay, let's shift gears to those scientific agents. How are we measuring whether AI can actually contribute to, genuine scientific discovery and research? That feels like a whole other level.
It is. We've come a long way from those early benchmarks like ARC, Science QA, and Science World, which were mainly about knowledge recall and basic reasoning.
So knowing the facts and making simple inferences.
Yeah. Benchmarks like QPASPER, QSA, and MS2, they focus on those more sophisticated skills like synthesizing information from scientific literature, putting it into context.
So more than just regurgitating facts, it's about understanding the connections, the big picture.
Exactly. SIRF evaluates the agent's ability to follow instructions across various scientific domains. But the really cutting-edge stuff is focused on those tasks that actually, contribute to the scientific process. Things like scientific ideation, that's measured by ideation. Experiment design, that's got benchmarks like AAR 1.0, generating code for experiments using benchmarks like SciCode and Science Agent Bench, and even writing peer reviews, which is evaluated by the quality of the feedback.
So it's not just about being a good student of science, it's about becoming a scientist in its own right.
Right. And these unified frameworks, things like AAR 1.0, MLGIM, Discovery World, and Lab Bench, they combine multiple scientific tasks to get a more holistic view of the agent's capabilities.
So it's like simulating a whole research project, not just isolated parts of it.
Exactly. And it really pushes the boundaries of what we think AI can do in this space. It's not just about retrieving information, it's about generating new knowledge, designing experiments, evaluating results, the whole shebang.
All right, let's wrap things up with those conversational agents. This is a big one, right? How do we evaluate their ability to interact with users, have a conversation, and actually achieve specific goals through that dialogue?
Yeah.
It's not just about sounding human anymore. It's about being effective.
Right. It's about action, not just words. And evaluating this often involves benchmarking against those, ground truth trajectories of those user-agent interactions and function calls. So you're comparing the agent's behavior to an ideal path.
So like a model conversation.
Yeah, exactly. But there are more flexible approaches too, where they simulate both the environment and the user to see how well the agent can reach a desired state, provide the right answer through dialogue.
So more like a real-world conversation where you don't always know what the other person is going to say.
Right, and they use those large crowdsourced data sets like ABCD, Multi-RZ, and SM-CalFlow, which provide real-world conversational data for training and evaluation.
So it's not just hypothetical scenarios, it's based on how people actually talk.
Exactly. And we've got those automated test generation frameworks like Almida, which use LLMs to generate different intents, procedures, APIs, those flow graphs, and even sample conversation paths. So it's like having an LLM create the test cases for another LLM.
It's like the AI is evaluating itself.
Kind of, yeah.
Yep.
LLbench focuses on those dynamic conversations with simulated users, specifically in those customer service domains. They incorporate databases, APIs, and policies to make it really realistic. And Intelligent, that's an open source framework for automatic benchmarking. It takes those system schemas and policies as input and uses simulated dialogues and those critique agents to evaluate how well the agent is performing.
So it's like having an AI supervisor watching over the agent, making sure it's doing its job properly.
Exactly. And it all comes down to measuring, how well the agent can actually complete the task, whether it's following the rules and that overall quality of the conversational experience.
Okay, we've talked about those fundamental capabilities and how they're evaluated in those specific applications. But now, what about those agents that are designed to be more general purpose? Those ones that are supposed to be capable across a wide range of tasks? How do we even begin to evaluate those?
Right. As LLMs become more general, the agents built on top of them also become more general, which means we need broader evaluation strategies.
Because you can't just test them on one specific thing anymore.
Exactly. So these benchmarks for generalist agents, they often try to assess those capabilities across multiple domains and tasks, focusing on things like multi-step reasoning, interactive problem solving, tool use in all sorts of different contexts.
So it's like a decathlon for AI.
Yeah, kind of.
Yeah.
GAIA is a benchmark that uses those human-crafted real-world questions that require a broad range of knowledge and skills. Galileo's agent leaderboard specifically focuses on how well the agent can make function calls and use APIs in different scenarios.
So testing that flexibility and adaptability.
Right. Agent Bench provides a whole bunch of interactive environments to test those tasks that require interaction and decision-making.
So less about rote memorization, more about thinking on its feet.
Exactly. Then there are those benchmarks that assess performance in those full-scale operating environments, like OSWorld, OmniSCT, and AppWorld.
So like throwing them into the deep end and seeing if they can swim.
Yeah, exactly. These benchmarks test the agent's ability to navigate computer systems, execute those complex tasks, handle control flows, all that good stuff.
So it's about seeing if they can function in a real-world setting, not just a simplified test environment.
Right. And to evaluate agents in even more realistic professional settings, there are benchmarks like the Agent Company, which simulates a software company environment, and CRM Arena, which focuses on those CRM tasks, customer relationship management.
So it's like giving them a job and seeing how they perform.
Yeah, basically. And finally, there's the Holistic Agent Leaderboard, or HAL. That one aims to be kind of a one-stop shop by pulling together results from multiple existing benchmarks. It gives a more complete picture of the agent's overall capabilities.
So it's like a meta benchmark.
Right.
Benchmark of benchmarks.
Exactly. And the goal with all of this is to see if these agents can go beyond those narrow, specialized tasks and show us some real, genuine, general intelligence.
So can they actually think for themselves, adapt to new situations, use what they know in different contexts.
Right, and that's the big question, isn't it? Can we create AI that's not just good at one thing, but can actually learn and grow and apply its knowledge broadly? That's what we're all working towards.
All right, so we've talked about all these benchmarks, but setting up those evaluations, gathering data, analyzing the results, it all seems incredibly complex. That's where those evaluation frameworks come in, right?
Exactly. Those frameworks are the tools that make it all possible. They help developers systematically evaluate, refine, and improve their agents throughout the entire development process. We're talking about continuous monitoring, deep error analysis, the ability for developers to design and test their own specific scenarios.
Sounds like the infrastructure that